We're going to look at this function, f of x, and we're going to do a few things with it. The first thing we're going to do is we're going to go through and graph it just like we normally do. So reminder, it's in standard form. We want to go and find the vertex. So let's go and do that. So in order to find the vertex, as you all know, we're going to identify a, b, and c. So a is 1/2, b is -2, c is -1. Let me double check that. Looks good. From there, we are going to plug it into our formula that gives us the axis symmetry / the x-coordinate of the vertex, and that is -b over 2a. So in this case, I'm going to get -2 over 2a, which is 2 times 1/2, which is going to be 2 over 1 or 2. Okay? In regards to finding the axis of symmetry, do you have any questions? Okay, so remember we've actually done two things at this point. One, we have found the axis of symmetry, and that is the vertical line x equals 2. Two, we've also found the x-coordinate of the vertex. So we have the point 2 something. Our job now is to figure out the y-coordinate. The way we do that, as you all know, is I'm going to take our number that we just found and plug it into x into our equation. So I get f of 2 is going to be equal to 1/2 times 2 squared minus 2 times 2 minus 1, which equals 2 squared is 4. 4 times 1/2 is 2. 2 times 2 is 4 minus 1. So I get -2, -3. Okay? In regards to finding the vertex, do you have any questions? Okay, let's graph our function because we have our vertex, so we have everything we need in order to graph this function. Let's do it. So this thing is positive, a is positive, so it's opening up, which means it's going to have a lowest point at the point 2, -3. Let's do something like this. This should work nicely. Okay, so our vertex is at 2, -3. And again, just like we did for the warm-up today, I've got my axis symmetry, that green line. I'm going to imagine that the origin is the point, that blue point is the point 0, 0. I'm going to make my parent function real quick. So we get this, 1, 2, 1, 2, 3, and then should be here. So that's our parent function. Okay, there's our parent function. From there, we are then going to apply our stretch. Again, when it's in standard form, it's always a vertical stretch. So I'm going to take all the y values and multiply them by 1/2. So the point 0, 0 becomes the point 0, 0. The point 1, 1 becomes the point 1, 1/2. Its partner on the other side. The point 2, 4 becomes the point 2, 2, and its partner on the other side. And then the point 3, 9 becomes the point 3, 4.5, 1, 2, 3, 4, 4.5, and its partner on the other side. Okay. In regards to the graph, do you have any questions? No? Okay, let's talk about the new part here. So it asks us to give the intervals of increasing and decreasing. So notice, I'm going to do this. Let me move this graph up. So I'm going to say this is decreasing. Notice what's going on. It decreases. It's decreasing from the left all the way until it gets to the vertex. So it's decreasing when x is less than or less than whatever that x coordinate of the vertex is, which is, I think it's -2, wasn't it? It was +2, excuse me. When we're talking about increasing, decreasing, we're talking about the interval which it's doing it, so we're talking about the x value. Okay, it's decreasing for all values that are less than 2. So all x values that are less than 2. It's increasing, notice, as we read from left to right, it's going up as we go forward. So when x is greater than 2. In regards to increasing, decreasing, do you have any questions? And then finally, it asked us, does this thing have a minimum or max, and what does it have? Would you guys agree? There's a lowest point on the graph. That's the vertex. So it's got a minimum. And we say it's y equals the y value of the vertex, which we said was -3. In regards to that, do you have any questions? No?